Hello and welcome to this session on dealing with the challenges of performance at scale. And let's think a little bit first of all about the why. So one of the key, if not the top concerns of CEOs and their colleagues today is the competitive impact of technology on the business. And as far as we can see, this concern is going to continue to grow and evolve as we look into the future. In the past, we've seen innovation in technology disrupt traditional markets and working practices, and we've also seen technology advancements reduce the cost of building and scaling businesses 1,000-fold. There's no doubt that technology is both an enabler and a potential blocker to your business. Essentially, if you're not using your technology and your technology is not performing the way it should, and it's not evolving fast enough to meet your current and then your future needs, your competition is benefiting and growing while you're not. You're basically struggling to get back to a baseline performance that's already been passed. For our purposes today, we're talking about software technologies and therefore software development. Whether you're thinking about software development for your own internal purposes or to sell solutions to your customers, getting left behind is going to be the ultimate sin. Over the last decades, investment in software technologies has grown manyfold, and companies try and leverage its benefits. And many organizations today no longer think of themselves in traditional business terms. It's been said the banks now consider themselves to be software development companies rather than retail banks. And indeed, many new and challenging startups have entered the banking market on the back of their software platforms and technology innovation. Ask any of the big four banks about this, and I'll bet you get the same answer. They're all looking to leverage software technologies to better engage with the customer base, offering better services, and of course, better engagement and therefore retention of that customer base. And at the same time, legacy software that exists within a lot of these large enterprises and large corporates barely meets the current functional needs, let alone the future needs of the businesses, and needs a major overhaul. So these are all presenting significant challenges to businesses today. Just a few examples to lift from HSBC's 2015 announcement. They're looking to invest essentially $1 billion in digital transformation to save $5 billion across a couple of years, actually, I think ending this year. And this is one of the many ambitious programs that are around the globe that are focusing on taking a traditional business, digitally transforming it into a new evolution, and getting much, much closer to the customers and actually delivering what customers come to expect today. Ford, as another example, has acknowledged that the old customer interactions are long gone. The contact with the customer used to be the occasional advert, an annual service, or a once-in-a-while car purchase, and some maybe magazine articles, etc., about new models, etc., coming out. Today, mobile and online apps mean there's a constant touch point with the customer and up-to-the-minute brand awareness. No doubt you've all seen on Facebook and other social media the constantly adverts pushing the brand and keeping that awareness up. And let's not forget Kodak, who felt that digital technology and digital photography evolution will not touch them and their market position. So what does this mean for us here right now today while I'm talking to you? Well, I've already highlighted the impact of software development, positive and negative, on businesses today. And of course, software development means software development teams. And my focus today, development tools. So within organizations such as yours, Atlassian products, there's Jira, Confluence, Bitbucket, Bamboo, and the other suite elements that wrap around these become mission critical and are permeated through the software development teams and across the organization. In the not so distant past, Atlassian tooling was the suite of choice for small development teams and companies with exemplary point solutions. Over time, these tools have gained traction to the point where they are now featuring as the tool of choice for enterprise-wide centralized solutions. And mission critical means that there's something you need to think about and something you need to do something about. And we feel there are three key areas to consider. These are performance, reliability, and governance. All of these points apply generally to software and software development as a whole, but let's think about these in terms of your software development tooling. Now let's tackle governance first, as it raises some of the challenges the other two will have to address. What many organizations are finding is that Atlassian products are spread across their development landscape in a relatively uncontrolled fashion. Uncontrolled in that there's been no centralized direction on what and how, and this has led to a disconnect between how different areas of the organization operate, and this leads to significant challenges around reporting, common working practices across the organization, and a potential lack of proper controls. I found that many organizations have accepted the use of Atlassian tools in the past, but only if you run it yourselves. In other words, Mr. Development Team, if you want to use it, okay, but you're on your own. And of course, I've seen this with varying degrees of success. Often the most expensive technicians become the original owners of these systems, and they're often the driving force behind the implementation. And often that leads to the fact that those senior technicians don't have the time to then do their day job, so they start sharing the load across multiple administrators, and you can end up in a nightmare situation. So alternatively, you end up with systems with little or no control, hundreds of administrators, and you essentially can release your high-paid techs, but in the first instance, you burn the precious hours of your best resource, and the second you get anarchy. So one example I like to use, because it was particularly interesting, shall we say, was a company that had well over 100 administrators for a couple of thousand user strong system of Jira. We were looking at about 250 different workflows and approximately 800 custom fields, essentially total anarchy. And one day one of those admins decided they didn't want story points and managed to switch it off for the entire organization. Now luckily that's something that's easily reversible, but it has the potential to do great harm. So not only was this system in a state of anarchy, but it's a highly complex system, and complex systems in Jira, and in fact many tools, mean performance impact. And how can you ensure things like Sarbanes-Oxley compliance are met when there's no enforced segregation of duties, where one of your developers who has admin access because they need to manage your project for you can modify their own procedures and bypass the checks you need? Now, I'm not saying people are going to do this, but these things can happen also by accident, unintentionally, or just to get something through because we've got a critical issue we need to sort out. And suddenly you're not complying to regulations that maybe affect your industry. There are a lot of very important compliance checks that are imposed on a lot of industries. Not only are you going to potentially impact you legally, but if you have the ability to get code bypassed checks, tests, etc., and get those erroneous code into production systems, you can end up with severe impact on how your, for example, a bank trading floor is operating. And reputation and financially damaging situations can occur very, very easily. Not only all of this, but decentralization in this manner can result in multiple backup solutions, and to be frank, sometimes none, multiple infrastructure provisions, a plethora of versions across the organization, no standard methodologies across teams, and a lot of unnecessary overheads. And over the last year or so, we've seen a significant trend in organizations wanting to get back central control of these mission-critical applications. So by adopting Atlassian tooling centrally and bringing back governance to a central team, organizations can address a lot of the problems I've just been talking about. They could put the necessary controls in place and enforce some processes and some standardization for reporting and management purposes, while allowing teams to work in their own way by putting in place things like a tools advisory board where changes in workflow, etc., can be managed, but also limiting the amount of anarchy, for want of a better term, that can exist in those systems. So management, reporting, backups, infrastructure, and all these important things can be dealt with in one place. Common theme we're seeing is where possible to implement a single central instance that all teams will use. This is the benefit of a simplification of a lot of things, but then there are challenges around performance and reliability with a single stack. Could governance be achieved by simply taking over the existing instances? Well, yes, it could, but you don't really achieve any degree of simplicity. And while you do get some central governance, you still end up with a maintenance nightmare. And you could also have to support a divided landscape, which will undoubtedly have version variants across the stacks, not to mention disconnects in information flow, and challenges of, okay, I need to do something for Bill's team, where do I go, where's Bill's team system? If everything's in one place, you overcome a lot of those issues. Of course, teams will challenge this because they want to work in their own way, they want to work flexibly, they want to have the ability to change their processes as and when they want to. Well, that can be achieved with some of the latest innovations in Jira being the main tool where process actually impacts people. But that needs to be restrained a little bit. There's a balancing act to be struck between that central standard control where everything's locked down and complete anarchy where anyone can do anything they want, and you end up with lack of consistency. So what we actually look at a lot of the time is saying, okay, to a certain extent, it really doesn't matter how teams actually develop code, as long as, let's say, for example, 4 key things for an organization are passed through, 4 key states within your workflow. For example, to do, in progress, development done, delivered being those 4. Now, if every workflow went through those states and we can monitor just those states across the application, then that could give us the level of management reporting we need in terms of progress, performance of teams, etc., that is required for capacity and resource planning and everything. But potentially between those states, we could allow teams to do whatever they want, whatever meets their needs, which is the agile approach to develop software in the way that makes sense for the product you're building, the team you've got, and the tooling you need to use to deliver that. So, on the presumption that centralization and consolidation is the way forward, let's think about the challenges of performance and reliability. How can you scale a single instance to support, let's say, 40,000 users? So performance is second on the list, and although the performance of people across the organization is an important factor, I want to concentrate on the performance of the development tool stack. Poor performance has many implications, not least of which is on, of course, productivity. But poorly performing systems not only slow down delivery and reduce productivity, but can cause a lot of negative feelings and even demotivation in the users. Putting a developer hat on, why should I get my head down and burn through a load of development on code, on a story that I've been assigned, if I know that pushing it back to the central teams is going to take an age to get a build and test results? So we expect these days that the tools we use, the applications we interact with, will respond in a timely fashion that we as human beings are used to. And that is that, essentially when we communicate with someone direct, face-to-face, one-to-one, we have a conversation. I say something, the person I'm talking to says something back to me, and it's a very interactive and continuous flow of information, and that's what we expect nowadays from our software applications. So that's what we would expect from our development tooling. Now, Atlassian have been conscious of the performance challenge of their system for some time, and have been working hard to address the issues even before they became impacting on businesses. And this is not only through improvements in their products, but also in delivering what's called Data Center Edition. So Data Center Edition, or DCE as I'll refer to it now, is a cluster-based solution allowing horizontal scaling across multiple low-cost devices rather than vertical scaling, which of course always has its limits and generally has expense implications compared to a load of small, cheap devices. So one could consider branching out into multiple instances of tools, as we were talking about just now, for smaller groups of teams, but that goes against the grain for a number of reasons. So multiple instances cause headaches, as we saw in the governance element earlier. And when you're thinking about developmental organizations in the thousands or tens of thousands, that could become an absolute disaster. In fact, centralized instance is the way forward, while retaining, some flexibility for the end user. So let's consider, for a conservative example, a development team of 500 who, through simple performance challenges, lose just 5 minutes of productivity each working day. For a team that size, and thinking about average salaries for developers, that's going to cost your organization at least £200,000, let's say $250,000 per year, and that's for 500. And that's a conservative example, and we haven't considered things like personal performance drop-off through frustrations. The costs of poorly performing development staff could be considerably higher. If you think about potentially frustrations, etc., learning staff turnover, you've got direct replacement costs for staff, etc. So just simple performance of the system itself can have a huge impact in many areas. So Data Center Edition, Confluence, Jira, Bitbucket, directly addresses performance issues, spreading concurrent usage across multiple nodes. Rather than invest in massive amounts of memory and processor power in a single instance, you can leverage a small number of small nodes to achieve the same results. And testing shows that the scaling is pretty linear. If we look at the graph here, number of operations a minute and the capacity of the system really does align very, very well to the number of nodes that are available. Bit of an interesting sideline here. So DCE addresses performance scaling issues by effectively and efficiently spreading that load across multiple devices. But what if that load has significant peaks and troughs? Let's say that the loading is very time dependent. Is it efficient to have all of those nodes operating all the time? That could cost unnecessary money. When DCE first launched, we at Clearvision conducted a few experiments, and through some fairly simple orchestration and monitoring tools, we're able to have a DC instance that flexed automatically to scale to load. Based either on time of day or loading the nodes in questions, we can use tools such as Puppet, Chef to instantiate new nodes when loads peak, and then spin them down again and destroy them as demand drops off. So performance for a centralized tool stack serving thousands of developers can be addressed by DCE. Let's also think a little bit about reliability and close the loop. So when you've got lots of distributed and localized instances, the downtime impact from a failed instance really only impacts numbers in the tens of hundreds, the smaller teams that are directly using that system. So the cost is relatively limited. As we've noted, however, and discussed, the way forward for organizations is pretty much around centralization. When that's experiencing system, that's impacting a large number of users, and the costs soon mount up. So let's consider a development team of 500 users again who are significantly impacted by one of the key systems going offline. And it takes an hour to get that system back and operational. And if we assume the teams are significantly impacted by that downtime, and remember these systems are mission critical, the cost to the business of the lost productivity for that hour is directly in excess of £10,000, let's say $12,000. And that doesn't include the cost of delay that might be impacting things. So planned work across all teams has now been delayed. That could mean delays in software release, and especially as you drive towards DevOps, continuous deployment, etc., system downtime of these critical systems can really impact your deliveries out into the outside world. You've also got additional damage to reputation, missed deadlines, potential legislative costs if you miss a critical deadline or something like that. And let's think about bigger teams. 500 users is relatively small. And we're looking at multiple organizations, engaging multiple organizations now, where they're talking about 10,000 users or more. And one incident a year is pretty unlikely. So if we think about 3 instances and those bigger number of users, the direct costs could be more than £600,000, $200,000 per instant. In dollars, $700,000, $750,000, potentially going down the pan with a system that is essentially unreliable. So again, Data Center Edition comes to the rescue and also addresses reliability. Due to the clustered nature of the applications, the service is not dependent on any single node for delivery. There are no single points of failure if the system is implemented properly. Loss of a node due to machine failure simply means that the concurrent load is spread across the remaining nodes and service continues without any downtime. When sizing a DCE implementation, you obviously need to give some thought to what would occur if you lose a node. In this instance, if you're happy for performance to potentially suffer a little bit as users are spread across the remaining nodes, you could just go with a sufficient number of nodes to support your peak loads across the organization. However, you could build in some performance redundancy. What we often say really is think about, essentially, let's go for a 4-node system where 3 nodes just operating on their own can deliver the performance that's required out of the system. Now, so there's some developments in Data Center Edition that's been happening recently that allows high availability across data centers. And this is achievable for most of the applications. And given infrastructure that can support automatic traffic switching between 2 distributed data centers and data and database replication, which is assisted by the applications themselves, DCE can be implemented to automatically switch over when infrastructure issues occur with minimal impact. It's not with that particular system completely highly available across remote data centers. But an interesting sideline here, we mentioned some experiments we did DCE earlier on. But we also looked at something else. So when we look at taking that auto cluster repair and auto scaling feature, then we can detect actually when a node dies. So if we suddenly find that a node has gone down and the system load and demand requires that another node is there, then that automation that we talked about earlier can automatically spin up that node. So actually you don't need to think too much about providing sufficient nodes that the failure of one doesn't affect performance, because the system's never going to be down that long. It will essentially self-heal. So while it self-heals, of course, the management team, the infrastructure team, the tooling management team can investigate cause of the failure and take steps to prevent recurrence. A second sideline is that these applications support a dark node concept, which essentially is a node that is kept up to date with all the customer-facing nodes, but actually doesn't interact directly with the customers. Now, previously that's been used for things like JIRA indexing, maybe bulk transformations, bulk operations against JIRA, etc. Not necessarily required anymore if the load balancer technology can actually understand and a facility that's been incorporated into DCE, which allows it to notify a node that it's notify the load balancer that a node has gone offline for a particular reason, i.e., you've taken it offline deliberately to do a reindex, for example, and then the other nodes just automatically become part of the ongoing load, or take up the ongoing load. However, this node gets no traffic from the users itself. So we did some experimentation. This is theoretically possible. More testing to be done, we think, but it's an interesting sideline at this moment. In the fact that if you put a dark node, part of your active system, into your DR system, and if you've then got global network switching that is capable of understanding that your primary site has gone offline or has some major issue, and switches automatically over into your DR secondary node, there will be at least one node there that is configured and now to be an active node, formerly a dark node, now an active node. So your users will transform onto a single node, and in testing, initially, it looks like they all take up and operate effectively under that new system. So an interesting potential use for dark nodes. So let's wrap up now. Only got a few minutes left. Software technology is critical to today's businesses if they're going to retain competitive edge. And software development tooling is mission critical to maintaining that edge. Proper governance of the software development tool stack means centralization, to a certain extent standardization, while remaining flexible. And for large organizations, scaling that development tool stack means taking measures to preempt performance and reliability problems. So Atlassian data center tools give you a platform on which to build reliable, scalable development tooling which supports your business and enables that positive competitive impact you all now need in the future and today. Thank you for your attention. Got a moment or two for a couple of questions. Let's see what we've got here. Okay, so question one, is consolidation and centralization the right answer? Would decentralization address all of the performance issues? Well, as I was alluding to earlier, yes, it would. However, in larger organizations, that really does give challenges around a certain element of standardization and centralized control. So what you'll end up doing if you decentralize everything is essentially having to build out management tooling teams, tools management teams in multiple places, and across an organization that's striving to these days standardize on things like DevOps, continuous deployment, etc., and understanding much more about the organization, how it's operating, to try and get some predictability out of what it's doing. You then have a challenge of how do you make sure all those systems are operating the same? How do you share information from all those systems? And you know, that centralization answer can really prove beneficial. Okay, question two. What advice would you give when starting to build a reliable solution? Well, I think the key thing is to think about what are your actual requirements. What's your RTO, etc. So, you know, how long can you afford to be down? And if you're saying we need to build a highly available, reliable solution, you've got to look for issues around single points of failure. So it's all well and good to implement DCE, for example, and just to use a crude example, have a single database instance that's not redundant, not resilient in itself, and therefore becomes a major single point of failure. So look at the entire landscape from the end user's perspective, because the other element is, of course, you could have this fantastically highly available, even potentially go in the future far as fault-tolerant system that completely delivers that ultimate in reliability. And then your users are sitting behind a broadband connection that's subject to a JCB digger just digging the road up outside the building. So you need to think about the entire big picture from the endpoint all the way through to the final delivery. And this is an interesting one we often get asked. So how do we know what size to make our systems in order to ensure performance? Short, crude answer is you don't. I suppose the real answer is really that things such as complexity are really the key elements that affect performance. And if you take that JIRA system I alluded to earlier, that system, because there's so much complexity in it, so many custom fields, so many workflows, so many different ways in which JIRA needs to think about itself every time it does a single operation inside, that's severely impacted by not the number of users, although obviously the number of concurrent users is a factor, because that obviously elevates demand, but a simple instance with 10,000 users and one workflow that everybody uses will outperform any day one with maybe even 100 users and 100 workflows. So you really need to think about complexity of the system, and today we have a huge advantage over at least maybe even 5 years ago. Virtualization and cheap virtualization means that we can build a system that we believe will reach base level of performance. And then we monitor it. Well, first of all, we test it when we first deploy it. So we have a baseline. And then we continue to test and monitor it as our users actually interact with the system. And, excuse me, we then have the ability to flex and adapt that system as our demand grows, or even if we actually scaled it wrongly a little bit in the first place. So we often with customers, we will make a reasonable, educated guesstimate, estimate of what system sizes need to be, but remain conscious that things might need to change over time. Okay, hopefully all that helps, and hope that's excellent for everyone, useful information. Please contact us if you want any further information. The contact information will be supplied to you. I'm slightly over my planned 35 minutes, but thank you all for listening.